Welcome back, students. So last class we discussed about velocity time graph. 4 cases we discussed, and in that video I told you with the help of the third graph, means the velocity time graph of an object when it is in uniform accelerated motion, but it is not initially at rest. But it is not initially at rest means the graph is not starting from the origin. So with the help of that graph, we need to find the 3 equations of motion. We need to derive 3 equations of motion. So first one we will do it here. Okay. So for that I will draw the graph. First equation of motion. Here we are doing it with graphical method, means from graph we will derive the equation. From equations we can derive. Okay. So different methods are there to derive the equations of motion. In 9th standard we will discuss about graphical method, or from graph we will derive the equations of motion. So first I will draw the graph. So this one is the time axis, x, time in seconds, y axis, velocity, SI unit, meter per second. This one is the origin. Here the graph is not from the starting from this origin, it starts from here. The graph is not starting from the origin, it starts from this point A. So mark it as A. You can name this point as B. Now we will draw a line to the x axis. Let that be C, this point be C. So this much is represent time, this much is the initial velocity u, this much is the final velocity v. Now I will draw a line parallel to the time axis from the point A. It meets this line BC. Name it as D. Again from this point I will draw a line to the x axis. Name it as E. Okay. So we did the graph of velocity time graph for an object which is in uniformly accelerated motion, but the object is not starting from the origin. Means the graph is not starting from the origin, or the object is not initially at rest. Okay. So this is the shape of this graph. This AB is the graph. Now I joined B, point B towards the x axis with a dotted line, and that line meets the x axis at point C. So OC represents the time. OC represents the time. OA represents the initial velocity. It is represented by the letter U. This BC represents the final velocity. It is represented by the letter V. Now I will draw a line parallel from A, parallel to the time axis, and it will meet at this line BC at D. I will draw a line from A parallel to time axis, and it will meet this line BC at D. Now I will draw a line from the point B towards the y-axis and I mark the point as E. Okay, it's clear? Now you have to consider the velocity time graph of an object under uniform acceleration. Initial velocity is not equal to 0. Initial velocity is not equal to 0. So, initial velocity is given like this. Initial velocity is represented by the letter U, that is equal to OA, that is equal to OA, that is equal to, now what is the shape? OADC. Actually it's a square or a rectangle. It can be a square or rectangle. So actually when you draw it, it should be a rectangle. Okay. So this one and this side OA and DC will be same. So OA equal to DC. Now final velocity it's represented by the letter V, that is equal to BC. Final velocity is represented by the letter BC, means this much from here to here, that is BC. Then time T equal to OC, that is equal to this line and this line is same. This one and this one is same. So OC equal to AD. OC equal to AD. Now from this graph we need to find the acceleration. From this graph we need to find the acceleration. So the slope of this velocity time graph is equal to the acceleration. We need to find the slope of the velocity time graph. So acceleration equal to slope of VT graph. Slope of VT graph. Slope of VT graph. So I will draw this graph once again. This one is velocity. This one is time. This is a graph. A, O, B. This point is C. This one is D. This is a graph. Okay. Now I will consider 2 points. This one. I will consider 2 points. Here. In velocity time graph, we calculated the slope by using the equation y2 minus y1 by x2 minus x1. Okay, y2 minus y1 by x2 minus x1. So we will write the like this: y2 minus y1 by x2 minus x1. That is, what is the change in y-axis? What is the change in y-axis divided by what is the change in x-axis? So, if I consider 2 points, this one is first one, this point A and this point B. I am considering 2 points A and B. So, this much change is there in y-axis and this much change is there in x-axis. So, the y is equal to y2 minus y1 and x equal to x2 minus x1. Okay. So, what is the change in x? Suppose the object is starting from A to B. What is the change in x-axis? What is the change in y-axis? Okay. What is the change in x-axis and what is the change in y-axis? So, instead of writing y2 minus y1, I will write it as y by x. Okay, y by x. Now, from this graph, what is y? Y is this much. From this graph, y is this much, that is b d by x is this much from here to here, that is x, that is a d, b d by a d. Now, just I will draw this portion here. This point is B. This point is D and this point is C. How will you find this portion? How will you find BD? BD is equal to or BD plus DC equal to BC. This one plus this one equal to the whole thing. So, BD plus DC equal to BC. Now, from here how will you find BD? BD equal to BC minus DC. BD equal to BC minus DC. BC is this much. The whole thing is BC minus DC, this much. So, you will get BD. Now, you will substitute this BD here. Okay. So, that is equal to BC minus DC by AD. BC minus DC by AD. Now, from here, what is BC? BC, that is V, isn't it? So, BC equal to V, BC equal to V minus, then DC, DC equal to U. So, minus U divided by, then AD is equal to time T. So, that is equal to T. So, you got an equation like this, A equal to V minus U by T. Now, you cross multiply this one. A into T equal to V minus U. A into T equal to V minus U. Now, take this U to this side. So, AT plus U equal to V. AT plus U equal to V. So, how will you write the equation? That is V equal to U plus AT. V equal to U plus AT. This equation is also known as velocity time relation. Velocity time relation. This equation is also known as velocity time relation. So, how we derive this equation? First, you have to consider the velocity time graph of an object which is under uniform accelerated motion, but the object is not initially at rest. The object is not initially at rest. So, initial velocity is OA, or that is equal to dc. Final velocity is V. Time is OC or AD. Now, if you want to find the acceleration from velocity time graph, acceleration equal to change in velocity by time. Acceleration equal to change in velocity by time. So, velocity is represented along y-axis and time is represented along x-axis. Change in velocity divided by time. Change in velocity by time. So, you need to find the slope of the graph, that is y2 minus y1 by x2 minus x1. y2 minus y1 means change in y, this much. Change in y divided by x2 minus x1 means this much AD. AD is the change in x. BD is the change in y. Then you find it from the graph. So, you will get it as BD equal to BC minus DC by AD, BC equal to V, DC equal to U and AD equal to T. So, you will get an equation like this: A equal to V minus U by T. You just cross multiply this A into T here. Just cross multiply this T to this side. So, AT equal to V minus U, or and now take this U to this side of the equation. So, AT plus U equal to V. Now, just write it in this way: V equal to U plus AT. So, this equation is known as velocity time relation. Velocity time relation. From this equation we can find acceleration. A equal to V minus U by T. That is acceleration. Initial velocity you can find out using the equation V equal to U plus AT. Then U you can find out, that is V minus AT, minus U equal to V minus AT. That also you can find out from this equation. Okay. So, this equation is known as velocity time relation. Okay. So, in the next video we will derive the second equation. Okay. So, this one is only for one day. Okay. So, derive it 5 times in your rough note and study it. Okay. Then we will go to the next video. Okay. Thank you.